Again, make sure those postulates and theorems, you get them, that's up to you. When I do collect binders, chapters 2 and chapter 3, have to have all those done. Make sure they're copied in there. The homework, we'll talk about the homework here in a few minutes. We're going to do this problem real quick. Mike Mustang owns 20 vehicles. He has forgotten how many cars and how many motorcycles he owns, but he knows that there are a total of 66 wheels. How many cars and motorcycles are there? Somebody help me out because I got to switch to the next screen. Remember that he's got 20 total vehicles and 66 total wheels.
Okay.
So that we can have that even though we're on the next screen. First thing, when you're in algebra class, the very first thing you have to do when you're doing a word problem is what? Anybody remember from algebra? Nobody ever seems to remember this because nobody ever does it. First thing, if you're doing a word problem, define your variables. What's that mean to define your variables? Tell what you're looking for, right? Well, in that problem, in that Mike Mustang problem, what were the two things that we don't know?
How many cars and how many motorcycles?
So cars, motorcycles. That's the two things we're looking for. When they say define your variables, what they mean is make up a variable for those things that you don't know. All right? Probably most of you normally pick what as a variable? A lot of people pick X and Y or A and B, right? But Derek is probably right here. It's going to make it easier on you if you pick what for cars? C. And probably what for motorcycles? Now, the bad thing with that is, how many variables do we have there? Is it easy to solve equations that have two variables in them? No, it's a pain in the butt. All right? Last year you learned 3 different ways in algebra class to solve equations that had 2 variables in them. All right? It was, first thing it was called, when you have more than one variable, called systems of equations. All right? So it was called systems of equations. One way that you learn to solve systems of equations, each one, when we set up our equations, each one's going to be a line. Where's the solution at for those 2 lines? Where they intersect. Probably most of you didn't like graphing too much to do it because it took a long time and it was real tedious, right? A lot of work. If you had a graphing calculator and you knew how to do it on there, it's not too bad. All right? So this one's probably not the way you use most of the time. Another one, substitution. Substitution is where you have a variable equal on a side of the equal sign by itself, and you take whatever it's equal to and substitute it in somewhere else. All right? And then the third way was elimination. What's elimination mean? Take out, get rid of, right? Get rid of something. This is probably the one that you use most of the time, and we're going to talk about that here in a second. Going back to the numbers for Mike Mustang, what's the easiest equation that we can have using our 2 variables and those numbers that they gave us?
Well, we can do M plus C equals 20.
Number of motorcycles plus the number of cars should equal the total, which was what?
20.
Does everybody agree with that equation?
Yeah. And then you could do...
Now the bad thing is, Justine, can we solve that equation? No, because it's got 2 variables in it. All right? So we need
That's the problem. Don't do it.
another equation.
C...
I'm listening.
C times 4 plus...
How do we write that? C times 4. Somebody help her out. How do you write C times 4? Do I write C4? Do I write it like, oops. Do I write it like that? Is that how you write it?
It's still time.
It is? Exactly. You write a 4C, right?
4C.
4C plus 2M equals 66.
Now, I'm going to turn hers around a little bit because I want to put it in the same order.
Yeah.
Right.
So how am I going to write it?
2M plus 4M.
For what?
C.
Equals what?
66.
Does everybody understand where we got that equation from? Dustin, that makes sense where we got that from?
From wheels.
What's 66?
And
Total number of
wheels.
wheels. How come you had to take M times 2?
Yeah, that's how many wheels motorcycle.
Motorcycles have 2 wheels, C times 4 because cars have 4 wheels. All right? Does anybody remember from algebra what form are both those in? What is it? I thought you said it. Scared? Standard form. Whenever both the variables are on one side, the regular numbers are on the other side, that's standard form. When you do elimination, that's the form you want them in. Standard form. All right? Does anybody remember this? What form is this from algebra? Because we're going to do a bunch of this here in a couple of days. Slope, intercept form. Why was that called slope intercept form?
Because it's measured its slope.
It's called the slope intercept form because what's M stand for?
Slope.
Slope. What's B stand for?
Y.
Y-intercept. That's why it's called that. Ain't nothing in math that they don't call it slope intercept because John Slope and Joe Intercept found it. They call it that because that's what it's telling you. Standard form, it's just called standard form because that's the normal form that you write stuff in. Anytime we want to do any algebra, this is the form we write it in. All right? With elimination. When I was in school, we didn't learn it as elimination. We called it the multiplication addition method. The reason it was called the multiplication addition method is because guess what two things you do?
You divide it.
You what? Divide. You multiply, then you add. That's why it's called the multiplication addition method. Remember, elimination means we're trying to eliminate something. We want to eliminate one of the variables so that we can actually have an equation that we can solve. Right? So pick a variable. In this case, it really doesn't matter. They're both about the same. M. Looking at this, what's the coefficient for this bottom one on the M term? 2.
1.
This one up here is 1. What do you have to do? What coefficient needs to be up here so that these two terms are opposites? 2.
No, wait.
What's the opposite of 2? Negative 2. So we want this M up here to be negative 2. Well, what do you got to do to 1 to get it to be negative 2?
Yeah, just
Multiply it by negative 2. So we want to multiply this whole top equation by negative 2. Right? Remember any of that from last year? You don't remember any of that, Chris? What's 2 times M? Or I'm sorry, what's negative 2 times M? Negative 2M. And all I'm doing is rewriting it down here below. What's negative 2 times C? What's negative 2 times 20? Negative 40. This equation now is sort of gone. All right? We did the multiplication part. Tiffany, what do you think we're going to do next then? Addition, right? We're going to add. We're going to take these two equations that we have, and we're going to add the like terms. What's 2M and negative 2M give you? Nothing. They cancel out. They're eliminated. That's what we wanted to do. What's 4C and negative 2C give you? What's 66 and negative 40 give you? 26. Everybody agree with that?
I'm sort of have to.
What's nice about this new equation?
All I have to do is divide the
How many variables in it? 1. Is that something we can solve, Graham? Yeah. What do we do? Divide by 2. What's C equal?
13.
Everybody agree with that? 13? Now, Brian's going to explain to us what that 13 means. Probably 13 fish, right? 13. It's nice that we use C there because that helped you connect the two, right? So we know that Mike Mustang has what? 13 cars. What can we do to figure out how many motorcycles he has?
Minus 13 from 20.
All right, if we go back to this equation right here, We know he's got 13 cars. Subtract 13 on both sides, 20 minus 13, you get what? 7. Systems of equations. Make sure you remember how to solve those. From algebra last year, we're going to do a lot more of those as the year goes along. Dustin, all that makes sense? Remember any of that from algebra? You don't remember none of that from algebra? So you learned something today, huh? All right, open up your books to page 128. Everybody open up the books to 128. That was the homework. What we're going to do, I'm going to go over a bunch of it. Follow along because it's going to lead us right into what we're going to do today. We're going to go around the room. We'll start over there with Clayton, and you're going to answer questions for me. So everybody needs to make sure that you're following along, so we don't have to wait because we're going to hurry. If we get to you and you're not ready, we'll skip you and come back and make you answer like 3 questions. So everybody should be paying attention then, right? Problem number 4. Clayton, read problem number 4 to me so I don't have to go back over there and look at my book again.
Name all planes that intersect, name all planes that intersect planes that intersect plane ADM.
So remember, when we're naming a plane, we name with 3 letters, right? ADM is that green plane right there. Everybody see that plane? So number 4, give me one plane. 3 letters, right? Give me one that intersects that plane.
Plane BAJ.
BAJ. First one all day long, Clayton. That seems like the easiest one to me. Everybody else did a hard one first. And Wade kept that one till the end. I have no idea why. Give me another one, Jaden. Give me another plane that intersects this plane. ABK. That's the same one he just named. ABK is the same, the top here, right? JML, that's his front?
Yeah.
Is that intersected? Yep. Give me another one, Chris. So they named the top up here, they named the front. Give me another plane that intersects this plane over here on the side. LKB, which is this plane over here. Does that intersect that one?
Oh.
That's the only one that's parallel to it. It's only one in the whole picture you could have picked that didn't work.
ABC.
ABC? Everybody agree with that? Chris is just trying to show us how intelligent he is, picking the. He meant to say, you meant to say all planes except BKL, right?
Yeah.
I knew that's what you meant.
You knew what I was thinking.
Yep. Number 5. Tiffany, read number 5 to us.
Name all prisons that are parallel to
Line
line CD.
CD. Let me change colors here and we'll. Line CD is right back here. Does everybody see that? We want a segment that's parallel to that. Go ahead, Tiffany, give me one. line LM. Make sure you're using your symbols. I think they said segment, so we'll use the segment symbol. But make sure you're using the symbols. Is that what they use? Segment symbol. Give me another one. Graham, give me another one. We already got LM, so we don't want it anymore.
JK.
Line or segment JK.
Just kidding.
Give me another one, Justine.
AB.
Segment AB. Now, going back to this, did we name all of them over here at the first? No, I'm not gonna name all of them all the way through, I'm just stopping. Does everybody see that all those are parallel to that one, right? Number 6. Oh, number 6. I'll even read it for you, Jonathan, since I'm standing here. Name all segments that intersect segment KL. Yes,
Mr. Emerson, do you have Graham Jones?
yes.
Could you let him know that he will need to check with Mr. Touchwell about what bus to ride home, that it'll either be 8 or 16?
I will inform him.
Thank you.
Thank you. Did you hear all that?
I think so.
You need to write those numbers down.
8 and 16.
You want me to write them down on your forehead so you don't forget them?
I won't be able to see them.
Looking.
You look backwards.
Oh, then you think the 8 wouldn't be backwards.
Six with
KL, we want segments that intersect KL. Give me one, Jonathan.
KM.
Say it again.
KM.
KM.
Segment KM.
Now, every one of these, as we go through and we name these, what letters should be, there's 2 letters. What letters, one of the 2 should fall in what? The K or the L. If it intersects that, one of those 2 letters has to be in it, right? So am I gonna say AB?
No.
It's not gonna intersect it because it's not touching it. Give me another one. Derek, give me another one.
Segment LM.
LM. Give me another one, Trevor. CM. So from C to M right here, does that intersect KL? So why'd you tell me that? Say it again. There you go. Are there others? Yeah, there's a whole bunch of them. We're not gonna name them all.
There's only 6.
Is there only 6? All right, so
I figured it out during your meeting.
number, we're gonna jump to 7.
You're on 7.
I know that.
You said you're gonna jump to 7.
All right. You're gonna get a reprieve for a minute, whoever I left off on.
Huh? I'm not hearing what you said.
I said whoever I left off on is gonna get a reprieve for a minute.
I don't know
I didn't,
what it is. Oh, okay, I
I
got you.
didn't leave off on you, did I?
No.
Then you probably don't have to worry about what it means. I would hope you know what it means.
Doesn't it look like a breather?
Right. All right, what's the first letter they give us on number 7? P. To be a transversal, remember a transversal is any line that intersects 2 other lines in a plane, all right? So if I take line P here, give me 2 lines, anybody, give me 2 lines that intersect line P, R and Q. Give me 2 other lines that intersect line P,
CQ.
T and Q. Give me 2 other lines that intersect line P,
RT.
R and T. Now, since they're lines, even though R doesn't intersect line P in the picture, is it gonna intersect it somewhere? Yeah. So on 8, 9, so 8 and 9, is that what it goes? 10. All you're doing is taking the line that you want to be the transversal, leaving it out, and pairing up the other lines because they're all going to be coplanar lines that intersect that together. All right, does that make sense? These problems, and we're gonna skip the one that's on the next part that's like this because they're silly. All right, you take, this line is gonna intersect these other two lines at some point. So this line could be a transversal for any two other lines in that picture. So if I did, let's do line T right here. Give me two lines that T is going to be a transversal for. P and Q, Q and R, R and P. It's just pairing up all the other lines. Yeah. Now, when we do what we're going to do today, and we have lines that look like they're what to each other? Parallel. And then that line's going to be the transversal. You want to be able to pick that out, but it doesn't, you know, when you got all these lines that just intersect everywhere, it doesn't really help. All right, reprieve's over. Give me a second to draw this picture. If you watch nothing else all day, watch what I'm getting ready to do for this problem, this set of problems, and the next one. Because this is what's going to help you understand a whole bunch of the stuff that we do this chapter. If I put an angle in the wrong spot, please tell me. Where did we leave off at? Riley? Let's read number 7 to us. Or no, number, what is it, 11?
Yeah.
Identify each pair of angles as alternate interior and alternate exterior corresponding or consecutive interior angles.
All right, so I'm going to write these down. Alternate interior, these are all the angles, the pairs of angles that we talked about last time. Alternate interior, alternate exterior, consecutive interior, and corresponding. I know I abbreviated. If you can't understand the abbreviations, start to, because I'm too lazy to write everything out every time. Which angles did they give us?
7 and 10.
So angle 7 and angle 10. Chris, this is where I want you to watch, all right? 7 and 10. You cannot, for this whole chapter, you cannot look at a picture that's got all those different lines in it and figure out what those angles are to each other. If you do, you'll be lost. You're going to miss about 50% of the problems. All right? What you need to do is look at angle 7. I'll change colors here so I can show you a little bit.
Blue.
Angle 7's right here. For angle 7, we need that line, and we need that line. Everybody agree with that to make angle 7? To make angle 10, we need this line and that line. Well, what I'm going to do is split those off. These are our two lines. What's this line called again? This one right here? Transversal, right? Angle 7's here. Angle 10 is here. Now can Riley figure out what those angles are to each other? Now, I think here in a few minutes I'm going to make you write out. Let's look at one of them, because I'm going to have you write out, and this is going to be for a grade. You're going to have to turn it in. Explain to me what alternate interior angles are. Anybody?
Angles that are interior angles that are alternate sides.
Exactly. They're on the interior of the two lines, and they're on like opposite corners. Common sense stuff, right? That's the way all these names are. What are alternate exterior angles? Then explain that to me. Angles on the outside of the two lines on different sides, opposite sides. What's consecutive interior angles?
Side by side, interior.
they're interior angles, and they're on the same side of the transversal. Corresponding angles is the only one that the name doesn't really fit. The reason they're called corresponding angles is because I told you last time, when you take the two lines and you smash them together, corresponding angles are the angles that lay over top of each other. All right? So that's what corresponding angles are. So looking at 7 and 10 here. On the inside or outside, Riley?
Outside, inside.
Inside the two lines, right? These are our two lines. These are our two lines. They're both on the inside. So we know they're either alternate interior or consecutive interior. Which one is it? Does everybody see that? Those are alternate interior angles. Opposite sides of the transversal, both on the inside of the two coplanar lines. Okay? Graham, that make any sense?
Yeah.
Next one, what pair do they give us next? 1 and 5. So angle 1, I need that line, I need this line. Angle 5, I need this line and this line. So I'm going to come over here. Notice, I know Dustin says, I ain't doing all that work. I'm drawing it off, right? This is what you need to do. Come over here. We're going to have a quiz next time. Easiest quiz you'll have all year long. If you do this. If you don't do it, then about half of you will get about a 50 on it because you'll miss half the answers. I guarantee it. All right? So I need, for angle 1 and angle 5, I need this line, I need this line, and I need this is our transversal. 1 is there, 5 is there. Does that make sense the way I did that? Is it real hard to draw off this stuff? No, it only takes a couple of seconds. Not a big deal or anything. Angle 1 and angle 5. So Brian, interior angles, exterior angles, what?
Interior.
One's an interior and one's an exterior, isn't it? Can it be alternate interior then?
No.
No, because they're not both interior. Can it be alternate exterior?
No.
No. Can it be consecutive interior?
No, so it's gotta be corresponding.
It's got to be corresponding. Corresponding is the only one that one of them's an interior and one of them's an exterior. All right? Now look at what happens. If I take this line and shove it and lay it right on top of this line, not fold it, just smash them together, is angle 5 going to lay on top of angle 1?
Yeah.
And that's what it means to be corresponding. When you smash those lines together,
Oh, so pretty much like you cut that and just like.
and you like pick it up and lay it over there. So if I take this, grab it right here, lay it right on top of that, 5's going to lay on top of what? 1. Those are corresponding angles. 6 is going to lay on top of what? 2. Those are corresponding angles. All right? Does that make sense? So corresponding angles. What's 13 say, Dustin?
Angle 4 and angle 6.
Angle 4 and angle 6. Thought you were going to stand up when you started those off.
I'm not like really dozing off, I'm still listening. I have all the answers I
You said angle 4 and angle, sorry, I got sidetracked. Angle 4 and angle 6. 4 and 6, that's here and here. That's the same picture that we just had right here, right? So instead of me redrawing the picture because I'm lazy, I'm going to get rid of 1 and 5. 1 and 5, then we'll put 4 in there, and we'll put 6 right there where it belongs. Are they interior or exterior angles? Are they between the lines or on the outside of the lines? In between. So is that interior or exterior? Interior. Are they, so if they're interior, they're either alternate interior or consecutive interior, right? Are they on the same side of the line or opposite corners? Same side, right? So which one of these are they? Which one is it, Dustin? What is it? Consecutive interior angles. All right, Clayton, what's 14 say? 8 and 1. That's same picture again, right? So let's just get rid of 4 and 6 here. 1's here, 8's here. Interior or exterior angles?
They're alternating exterior.
Exterior, and which one is it?
They're alternating exterior.
Alternate exterior.
Yeah.
Does that make sense? Graham, you can pick all those out. Now, short of drawing everything off, because I know Chris is gonna be so lazy, he will refuse to do it. If it's on a piece of paper in the book or something, could I put my finger, my hand or something over this part and look at that?
Yeah, but it's on your arms too.
All right? But you can't see it as well, right? So you know to look at that. And then you can match up what kind of angles they are. But if you're trying to look at this whole picture this way, you're going to get confused. You got to split things off like I did here. Do what?
Just put your notes under one part with the other.
So if it's in the book, what I would do in the book, if I'm looking at something like this next picture we're getting ready to go over,
Just take a marker, just mark it down.
no. Put my finger over that, and then I should be able to. All right, the next one. This one's very, very important because this looks more like the picture that we would actually use. The reason for that. What looks to be true about line L and line M here?
Parallel.
They look like they're parallel to each other. Doesn't mean that they are, but with what we're going to cover today, they're going to tell us that those two lines are parallel. As a matter of fact, that quiz I was talking about that you're going to have next class, this picture right here looks identical to one of the pictures that's on that quiz. So help me out, Jaden. 15. What angles do they want for 15? 3 and 10. 3's here, so I need this line for 3, right? 10, I need this line and this line. So I'm gonna come over here. Just draw this line, draw that line, draw this. 3 is right here. 10 is here. What kind of angles are those to each other?
Consecutive interior.
Consecutive interior, very good. Consecutive interior. Now I know about half of you are saying, I can do that without drawing it, right? All right, so let's go through here, and instead of picking the angles that they picked, I'm just gonna pick angles. Let's do 8 and 14. What kind of angles are 8 and 14 to each other?
Those are
Alternate interior. Did you get that, Dustin? Sort of hard to look at when it's all that one big picture, isn't it? If you split it off, I'm telling you, it's gonna be a lot easier. How about, so you got Brian over here, he's still doubting me that I picked that out without doing it. You're just an idiot, Mr. Earl, so that's why you can't do it. How about 6 and 2?
6 and 2. Those would be the corresponding.
Corresponding, good. Everybody see that?
Yeah.
All right. How about 10 and 8?
10 and 8.
Consecutive interior. Alternating interior angles.
This is where you guys are gonna mess up at.
Alternating interior angles.
Haven't heard the right answer yet. How many lines do we want in the picture? Every time I've been drawing off stuff, how many lines do we want in the picture? 3. So if I draw 10,
Those have to be 4.
that'd have to be 4.
Have to be all 4.
Is that gonna help us?
No.
What are 10 and 8 to each other?
They're nothing.
They're nothing to each other. And you gotta be able, that's why I split it off, because sometimes they'll do something like that.
Do we just write nothing?
Well, if they ask you what kind of special pair those are to each other, then yeah, you'd write nothing. But on the stuff that we're gonna do today, when you can actually give each one of these angles a measure, what's gonna happen is I'm gonna tell you that angle 10 is 80 degrees. And a lot of you are gonna say, oh, well then 8 over here, that's an alternate interior angle with that, so it's gotta be 80 also. And it doesn't work. You've got to separate this stuff off. You know, if nothing else, get rid of that. Then you can look at these angles. Get rid of this side, and you can look at all those angles together. But you can't look at the whole picture together and not mess up somewhere along the line. All right? Yeah, I'm gonna spit on you in a minute, Chris.
It's gonna spit on me?
Yeah,
That's disgusting.
you won't ever be able to prove that it was on purpose because you're asleep.
I'm
I'll
trying to
say,
stay
man,
up.
it was, say it was an accident. I said,
Okay.
came out.
Keep your bodily fluids.
We're gonna skip over to problem 48. Problem 48. Dustin, read problem 48 to me because I can't read very well and that's an awful long paragraph.
I can't read very well, and that's a whole paragraph.
It's like, yeah, that's a regular paragraph.
Yeah, I've been smacking the shit out of so I
Read it.
I passed it to Brian.
Read. Come on.
I started reading.
So do I. Help me out.
Why is that teacher?
I'll tell you the first word, airplanes.
I read that.
All right, let's go then. That's probably the longest word in the whole thing.
Airplanes heading eastbound are signed and
Altitude. Good.
Level that is.
odd number of thousands.
All right, stop for right there for 1 second. So if you got an airplane that's heading eastbound, I don't know if this is eastbound, it doesn't matter, but we'll say it's eastbound. They give these airplanes an odd number. Is it doesn't matter. Nobody else knows. They give it an odd number, all right? So it could be something like 15,000 feet, 17,000 feet, 19,000 feet. Does that make sense? Could it be 20,000 feet? No, that's not an odd number. Go on.
Airplanes heading westbound are signing up to level an even number thousand.
All right, so airplane's heading this way. That's westbound. It's given an even number. 8,000 feet, 10,000 feet, 30,000 feet. Does that make sense? Why they do that? How come one's going this way, get an odd number, one's going this way, get an even number?
So they don't collide,
So they don't crash into each other.
which would be pretty cool to watch, but.
Not for the people on the plane.
Or the people under it.
Or the people under it, right. Now, I'll give you a break, Dustin. What they say is, just tell me the numbers. One of them's how many thousand feet? 34,000? So we got this plane. It's going northeast. We'll say that that's this direction. 34,000 feet. We got this plane that's going, or northwest, I'm sorry.
Yeah.
We got this plane that's going east. It's going to be something like this, right? It's at 24,000 feet. What kind of lines are those to each other? Skew lines. Right? And that's the way they set it up in air traffic control setting. They want them to be skew lines. So when Brian's out in the sky, supposed to be working or something, his dad sent him out to work, and he's supposed to be out there working, he's staring up in the sky looking at the smoke that's up there from the airplane, right? And he's going, oh man, those two planes must have crashed because their smoke paths crossed each other. Did they actually cross each other? No, they were skew lines. Right? One was above the other one somehow. I know if I ask your dad, Brian, that's what he'd tell me, that you get off track like that.
I actually do. I was changing
Probably.
brakes yesterday and I was like, what's that?
Something, a bug crawling across the floor. Hey, did you see that ant?
It was like,
That's not good when you're changing brakes. Were they just disc brakes or were they drums?
they were drums.
Oh.
I had to replace everything, the springs, everything.
That's really bad because
That little cylinder in
then you
there.
forget where everything goes.
No, I remember the little
You ever
cylinder
tried
in there
changing the- you ever
busted.
tried-
Like in
Bro.
half.
You ever tried changing discs on a 2005 Ford? It's terrible.
49 through 51, you go to build a gazebo. I'm starting off building this gazebo. I'm going to start building the front part of it there. What do I want when I put my boards together, what do I want these two boards to be to each other? Parallel. If they're not, what's going to happen? It's going to end up messing up, right? Now, I got this front over here, and I got a board that goes along the roof of the gazebo. So this is there, this is here. Do I want them to be parallel to each other? No, what kind of lines do I want them to be? Skew lines. I want them to never intersect, right? And that's, so for Graham here who says, we'll never use none of this stuff out in real life, he's probably right. He'll probably get married someday and his wife will want him to build a gazebo out in the backyard for her. And he'll say, I ain't doing that.
No.
And then she'll say, you will do that, or I'm going to kick you out of the house. I'm not going to feed you anymore.
For gazebo.
And so he goes out there and builds it.
You sound like you've known something about this.
2 days later, the gazebo's out there and she's sitting in it and it falls on her. And
You're laughing.
Graham might be laughing, but then he's getting a divorce and his wife's suing him and taking his house and his car and everything else. And
No, they only get half.
Moral of the story.
Not usually.
You keep thinking that, Clayton. Make sure when you go in and you talk to the judges and stuff, when you're getting a divorce, say, they only get half.
Free agent.
And see what happens.
Well, like they get 95%.
All right, just looking up here, just real quick. I was going to make you write something out, but since we only got like 30 minutes, I'm not going to do it. So, but that's good that you can add or subtract. Remember that math teacher taught you that. Looking at this, these arrows tell you that these two lines, A and B, are parallel to each other, all right? So anytime you're looking at a diagram, you see extra arrows on the lines, that means that those lines are parallel. Everybody understand that? Dustin, you understand that, right? So those are parallel. Looking at these lines. Tiffany, pick me two angles out of that picture. Angle 1 and angle 7. What special pair of angles are 1 and 7 to each other? Hear a lot of mumbling, no confidence. We got alternate interior, we got alternate exterior, we got consecutive interior, we got corresponding. Corresponding, everybody agree with that, 1 and 7?
Yeah.
Wait.
It's like,
Corresponding?
yeah.
What happens with corresponding angles? They lay over top of each other. I shove A so it lays over top of B. One gonna lay over top of 7? One would be over 3, wouldn't it? So they're not corresponding. What are they to each other?
Alternating.
No, it wouldn't be alternating because one's out, one's in.
Thank you, Trevor. They're nothing to each other. All right? So those two happen to be nothing to each other. Sometimes that happens. Give me 2 more angles, Chris. Pick me 2 more.
6 and 3.
6 and 3. What special pair of angles are 6 and 3 to each other? Alternate interior. Everybody see that? Give me 2 more. Dustin, give me 2 more.
1 and 4.
Say it again.
1 and 4.
1 and 4. What kind of angles are 1 and 4 to each other? Consecutive exterior. You could say that. This book doesn't use those angles. If I was doing 2 and 3, what kind of angles are 2 and 3 to each other? Consecutive interior, right? That name's all right. I would rather you use same side interior. Because does it make more sense? 2 and 3 are on the same side of the transversal and they're both interior angles. Now let's 1 and 4. What kind of angles are they? Same side exterior angles. This book doesn't deal with same side exterior angles, so you don't have to know those. How about angle 3 and angle 4? What kind of angles are they to each other? What happened? corresponding?
No.
3 and 4. Nobody's got any idea? You know why you guys don't have an idea? Because you're thinking just about those special pairs of angles that we've been covering. Have we talked about other special pairs of angles throughout the year? Yeah. What other kind of angles have we talked about?
Right.
What other kind of pairs of angles? Pairs. Wow, we need to take another vocab. Supplementary angles, complementary, adjacent, vertical, all those, right? What are 3 and 4 to each other? They're supplementary angles.
Could they be corresponding?
If I take these two lines, shove them together, 3 and 4 gonna lay over top of each other?
Take that side, yeah. I was thinking 3 and 7, put over top of 4. I don't
Yeah,
know
you
what I
can't
was
do that.
thinking.
That didn't help anything.
That's just,
So 3 and 4 are supplementary. Give me another pair of supplementary angles in this picture. 1 and 2. Give me another pair. 5 and 6. How about if I pick this pair? 3 and 8. What are they to each other? Vertical angles. What do you know about vertical angles?
They're the same size.
They're always the same, aren't they? They're always congruent to each other. So if I told you angle 3 was 70 degrees, what's angle 8? 70 degrees. All right? You still got to remember all that stuff. Supplementary, vertical. You still got to know all that and use it with the stuff that we're going to learn. Don't forget all that stuff. All right, today is the first. Go ahead and start copying this down. Notice on the bottom, the before, after, and effort, I've shortened it up instead of having all that written out. Hopefully, Brian remembers that you put a 1 through 4 in each one of those blanks, right?
I really didn't.
You didn't remember that? I know it's been a while since we did it, but. So before, you can do before right now. How much do you know about parallel lines? Jonathan, how much do you know about parallel lines? 1, 2, 3, or 4? 3. So Jonathan's going to put a 3 in there. Do what? Write quickly because I'm going to switch slide quickly. Please remember that the stuff that we write down here is your notes. Even though we're going to cover some postulates and theorems here in a minute, they still go in what section of your binder?
Notes.
The notes. Because the postulates and theorems we're going to cover, what I'm going to show you is the shortened form of those postulates and theorems that hopefully you start to write down for chapter 3. All right, what we're going to cover, dealing with parallel lines, be able to use properties of parallel lines to find angle measures, identify special pairs of angles, that's the same as what we were just doing, identify vertical angles, supplementary angles, corresponding angles, alternate interior angles, alternate exterior angles, consecutive interior angles, identify all those special pairs, be able to set up and solve algebraic equations using properties. This symbol right here, this symbol right here means parallel lines. If you're looking at a picture like on that last one that we were just doing, they give you extra arrows on the lines to show you that the lines are parallel. All right? If it's in a sentence, then they use this symbol right here to tell you that the lines are parallel. That makes sense? Remember, I did say binders will be due here before too long. We will. I have a sheet back there. I don't have it copied off or anything. I will try to get that out.
See, there's a parallel line. Right there on that clock.
Write down POST 3.1. That's all I want you to write down. Write that down. Yeah, you got it. So that says two parallel, right?
That's right.
That's what it says right now. So when Jaden asks you what time it is,
Two
e-
parallel.
every day when you're in this class, you say, it's two parallel, Jaden.
Yeah.
And he'll look at you like, what? Because he won't understand what you're talking about.
Well, I do now, so.
Postulate 3.1. This is the shortened form of postulate 3.1. Nah, you dumb thing. What we're going to write up here is the shortened form of postulate 3.1, and I'm actually going to draw a little picture here. What's that tell me about those two lines? They're parallel to each other. What's this line called? Transversal. All right? Postulate 3.1 says if you have parallel lines, this is the shortened form. Write this down. Then, and I'm going to write a bunch of abbreviations, so I hope you understand my abbreviations. What's that stand for? Corresponding angles are congruent. All right, Justine, give me a pair of corresponding angles in my picture down there.
2 and 3. 2 and 4.
Remember, corresponding angles, what do you do with the two lines?
Shove together to 1 and 6.
2 and 5.
2 and 5. 2 and 5, corresponding angles. What do we know about angle 2 and angle 5? They have to be congruent. They have to be equal to each other. So if I told you angle 2 was 60 degrees, what's angle 5 got to be? 60 degrees. Now, not only do you know that angle 2 is 60, angle 5 is 60, what can you tell me about angle 3? It's 60. What can you tell me about angle 8?
60.
It's 60. What can you tell me about angle 1?
It's 60.
What do you know about 1 and 2 right there?
It's 120.
It's 120. They got to add up to be 180, right? What can you tell me about angle 4?
120.
It's 120. What can you tell me about angle 6? 120. How about angle 7?
120.
So we knew one number, 60 degrees. How many other angles did we find?
4. You know those?
7. We found 7 other ones. Just knowing that one thing, just using this one rule and knowing that one thing. All right? And that's what you're going to have to do. You should be able to do that. Was that too difficult? Theorem 3.1 says if you have parallel lines, then alternate interior angles are congruent. Name me a pair of alternate interior angles in that picture. Trevor, name me a pair of alternate interior angles in that picture. 3 and 5. What's the other pair? Anybody?
4 and 6.
4 and 6. What do we know about angle 4 and angle 6? They have to be the same.
They have to be.
They have to be congruent, have to be equal, have the same measures, right? I'm going to skip down to theorem 3.3. It says if parallel lines, anybody seeing a pattern here?
Yep, there's parallel lines.
If parallel lines, then instead of alternate interior angles, alternate exterior angles. Ignore that crazy line that just flew off the side there. Alternate exterior angles must be congruent. Give me a pair of alternate exterior angles, Dustin. One and close. 7. 1 and 7. What's the other pair? 2 and 8. What do we know about 2 and 8? They have to be the same. 1 and 7 have to be the same. Remember, all this only works if these two lines right here are what to each other? Parallel. Didn't work with all that stuff we did last time, only if those lines are parallel. Now I skipped 3, 2 for a reason. Notice, these three that we just did, do they all look real similar?
Yeah.
Might want to put a big asterisk beside this one, because this is the one that's different. Now I say it's different, but guess what it starts with again? If you have parallel lines, what's the only special pair that we talked about last time that we haven't put in here anywhere? We got corresponding. Consecutive interior, right? And that's what it is. Then stupid pen. Then consecutive interior angles are, what's that abbreviation stand for? Supplementary. So that one's different. Maybe circle it. I don't know, something to help you remember, hey, that one's different than all the rest. The other ones say that the angles are always congruent, the special pairs. That one says that those angles are just supplementary to each other. They add up to 180. Give me a pair of consecutive interior angles in that picture. Riley, give me a pair of consecutive interior angles.
1, 2.
4 and 5.
Yeah, 4 and 5.
4 and 5. What's the other pair? 3 and 6. Now, was Riley wrong as far as these being supplementary? No, they're going to be supplementary, but they weren't consecutive interior, right? What are those 1 and 2 to each other? A linear pairs. Right. 3-4, theorem 3-4, and you're right, they are adjacent. What I'm going to do on 3-4 is just draw this picture. This is what it says. And then I'm going to write just a little sentence with it. You got these two lines, and they're parallel to each other. What's that line called again? Transversal. If this transversal is perpendicular to the first parallel line, what's it mean to be perpendicular?
Wow.
Same one.
Perpendicular means they form what? Right angles, right? So if that one's perpendicular to that one, guess what's true about the way it intersects the other? That's the same thing. It's also perpendicular to it. So if you know this, then what you know there is that all angles are what in this picture? All angles are right angles, or 90 degrees. All those angles are right angles. So if you see a picture where where the transversal is perpendicular, forms a right angle with one of the parallel lines, then you know all those angles are 90 degrees. So what's this angle? What's the measure of that angle right there? 90. How about that one?
90,
That one?
90,
That one?
90, 90.
They're all right angles.
It makes it like
Now, did we even really need this theorem? If I told you that's 90, could you have figured out that this one down here was 90 because they're alternate exterior angles? Yeah. And you could have used all the other theorems instead. All right, we're not going to actually write this down. Just name me a pair of first, what's these red arrows tell us? Parallel. Name me a pair of corresponding angles in that picture.
1 and 5.
1 and 5. Everybody agree with that? Corresponding angles?
Yeah.
Name me a pair of alternate interior angles in that picture.
2, 7,
2 and 7, good. How about alternate exterior angles?
3, 6.
3 and 6, 1 and 8. How about consecutive interior angles? 2 and 5, 4 and 7. Let's say you wanted to, or you knew angle 2. Angle 2 right here was 100 degrees. And all you wanted to find was angle 5. What's angle 5 have to be? 80. Because what do you know about consecutive interior angles? They add up to 180. They're supplementary. What if you knew angle 2 and you wanted to find angle 7? How much is it going to be? It's going to be 100. Could you find every other angle in that picture from just knowing that one number?
Yes.
All right, this I do want you to write down. Write quickly. Draw this picture. Oh, I thought you said you didn't have enough room.
Most of that look.
Oh. Which two lines in this picture are parallel? C and B,
Yep.
right? Are D and E parallel?
No.
No, so this is, again, this is the picture. On the quiz next time, it's gonna look almost identical to this. If they tell us angle 1 is 78 degrees, I'm gonna write that in there. They tell us angle 6 is 85 degrees. Don't go by my diagram, because it doesn't look like angle 6 is 85 degrees, it looks like it's more than that.
Well, I felt my geometry book last year.
Did you already pay for it?
Thanks.
I have a question.
You
Why
show
is
your mom or
there,
dad?
why is there three?
I didn't lose it, I
No,
just
I just
misplaced
didn't.
it for a while.
It's misplaced.
I just forgot. Alright, what you gotta do on this, pick me an angle. What angle you wanna find first?
11.
11. Right, if we want 11, this is what you have to do, otherwise you're gonna get lost. I need that line, I need this line, those are our two parallel lines. Which transversal am I gonna use if I wanna find angle 11? E. So this is what I'm gonna do. Over here to the side, I'm gonna draw this, I'm gonna draw this. That's our transversal. I know this angle's 85. Can I find all the rest of these angles?
Yep.
Yeah. What's this angle right here?
85.
85. What's this angle over here?
85.
Alternate interior angle, so that's gotta be 85. How about this angle?
85.
85.
The rest is
95.
The rest of them are what?
95.
So can I write all those in over here? Yeah. This one's 95, this one's 85, this one's 95, this one right here is 85, that one's 95, this one's 85, that one's 95. Riley, is that gonna be too hard for you? It's pretty easy, right? Now, the problem is, pick me another angle that we don't know. 3.
That's 78.
Are we gonna be able to look like here and say, that one and that one are corresponding angles, so it's gotta be 95? Doesn't work that way. That's why we split off the two parallel lines. This time, what transversal are we using?
B.
D, right? We're using this one instead of E. We're using that one. Well, we know that this angle over here is 78. So if I could ever hit my line again. If that angle's 78, what's this angle right here?
78.
78. Those are corresponding angles, right? My pen's off.
It was gonna be 72.
This one right here is going to be what?
78.
78. How about this one right here? 78. The others are 102. Should there be any reason that you ever miss a problem dealing with this stuff? All right? If you take your time and just take it, only took us about 4 or 5 minutes to do that whole problem, you should never ever miss any of these. You'll be able to do all those, Jonathan?
Yes.
But you can't do that one. Write this down. Wanted to do part of your homework for you, we ain't gonna get too much of it. This one's pretty important. This is like a special problem. It's called, or I call it, I don't know if that's what any other math people call it or not. I call it a crook problem. Why is it called a crook problem?
That's crooked.
What's crooked?
Angle.
H.
These are our two parallel lines. What don't we have in this picture?
Another line.
We don't have a transversal. Our transversal's like bent, isn't it? So this is what you're going to do on these crook problems. It's just, they're not very difficult as long as you just watch right now and follow these steps. If I had Clayton come up and draw a line through point H, and I told him I wanted that line to be parallel to line AB and line CD, and then I had Jaden come up and draw a line that was parallel to those through point H. Then I had Tiffany come up and do the same thing. How many different lines would I have on the board?
One.
One. Because how many lines are there that go through point H that's going to be parallel to these other two in our world? There's only one. So when we do this, that's the first thing we're going to do. We're going to draw a line right through there. and we're gonna say that it's parallel to the other two. Right? Now, you can't just draw lines wherever you want, but there's only one line in the world that can go through point H and be parallel to the other two. So if I draw that line, Riley draws it, Jonathan draws it, Derica draws it, we're all gonna draw the same exact line.
That's a road.
All right, does that make sense? If Chris was paying attention, he wouldn't be worried about, he wouldn't be sidetracked, that being a road. Now, we look at this, watch carefully so you understand this. I draw the top line and our new line. Clayton, focus. This is a transversal. This part right here is a transversal for those two. We didn't have a transversal before, now we do, right? This angle is 40 degrees. What's this angle right here gonna be? 40 degrees. What kind of angles are those two to each other? Alternate interior. So that means this right here is 40 degrees. What if I draw the bottom line and our new line? IH, is that a transversal for those two lines? Yeah. This angle's 70. What's this angle right here? Can I find angle H there now? How can I find that?
40 and 70.
40 and 70. Segment addition postulate, right? This plus this should equal the whole thing. How much is it? How much is angle H? 110. Is that too difficult? You watched right there. Should you be able to get every one of those right? Yeah, there's nothing hard about those. Just a different kind of problem. All right, don't write that page down because we're not doing the page.
You don't have no homework?
You have homework. It's not that.
I'm starting to get my hopes up.
I'm starting to get my hopes up that you're going to stay awake all day today.
It's tough.
You know it's tougher getting a job when you don't have an education.
It's not true. That is how I got the job.
It's not the job, it's what kind of job you want.
Exactly. Let me rephrase that.
I'm
Get-
working with probate.